Okay, moving forward into starting to blend these items together, right? The simplest element that I'm going to do to reach out from my I'll call it my glazing surface, right? So like this is the glazing, and that's kind of the shading, right? For all intents purposes right now, nothing super duper special, but so to reach out from that one and anchor it back to the surface, I essentially have to draw a line from one to the other, and then we can make it 3D by piping it like it's an actual hardware piece, or a number of other things that really make it hardware driven. I can show you multiple ways of doing it, but we'll use pipes for simplicity right now. So this subdivide surface needs to be deconstructed, right? So that we can get our edge points. So I'm going to go to surface. Actually, do I want to do a deconstruct? Maybe I don't. Maybe I just want to do a divide surface. I think I do. I think I just want to do a divide surface. I might not need that. Sorry, I kind of just changed my mind. So if I use my divide surface, this will allow me to take this surface and divide it this many times, so U and V. And notice how now I get a point in all of the anchor points of my original panel. That's good because it eliminates the duplication of points that I would have gotten otherwise if I used my subdivide surface. Do you all understand what I mean by the duplication of points? Yeah?
Like when you showed us a while ago how we had to get rid of, how there was like a copy of the same point
Yes.
on the same.
Yes, exactly. Thank you. So that's exactly what I mean. So if I use this instead, then all I have is one point in all of these locations. And the cool thing about it is I can go from the original surface there, and I can also do the same thing to my new surface right here. Pretty nifty. And ultimately, the very simplistic way of doing this is draw a line from point to point and pipe that line. Make it a hardware piece. So I'm going to go and go to curve and primitive, and I'm just going to draw a line. This says create a line between 2 points. And I'll just plug my points list from here and my points list from here, and it just starts to draw that hardware back to the original surface. And then to actually generate it into a 3D form, simply put right now, not worrying about the ultra fine detail, I'll go to surface and freeform, and I'll do a pipe. And pipe is just going to take all of these curves, and it's going to create a pipe around it. I can set a radius. 0 is less than, I'm going to just do this, I think, in inches. So I'm going to say 0 is less than 6. And in order to convert it to inches, I'm going to use a mathematical operator. So right now that's reading that as feet. So I'm going to do a mathematical operator and divide it by 12 to convert this to inches automatically. I want to take another quick aside and show you a new feature, and it's called expressions. So if you notice, I'm trying not to overload you with new features too many times. But if you have an instance where you want to do a quick mathematical operator, but you don't want to clog up your screen with all of the mathematics functions, you can use an expression on an input. So the pipe radius reads a numerical input. If I right click it and I go to this expression menu, oh hold on, I gotta move it. If I right click it and I go down here to expression, it has an expression editor, and the syntax for it, I believe, follows. I believe it just follows like your calculator syntax. Like if you have a TI-82 or 84 or whatever they are, just uses like, like x parentheses or parentheses x, minus y parentheses, to the 2. So anyway, this essentially, if you're going to divide it, is just going to be x divided by 12, because x is going to be your input, I think. It might take, yeah, there you go. I have to find an actual document that outlines all of the syntax. I really do need that. So anyway, this is going from 1 inch to 2 inches to 3 inches to 4 inches, all the way up to 6 inches. But I think 2 inches is probably most appropriate right now. And so here from the side, you can kind of see the rigor and the order that goes into actually constructing this.
Can you back up the Grasshopper?
Yes, I will. There is one thing that I want to clean up at some point. So I believe I left off pausing right here with the subdivide surface. I forgot to continue on in the video, but if you're watching the video, what I essentially did was I kind of decided that if this subsurface is going to create a point at all 4 corners, then I'm going to get overlapping points wherever those 4 corners kind of, I guess, overlap. So I'll have 4 points in that corner rather than just 1. So a better option was to use a subdivide surface right here under surface utility, divide surface. And this allowed me to take the original surface from this exercise and the new surface from that exercise and break it down to the same number of subdivisions, which gave me 1 point at every control point location. That would be these, that would be those, which I just basically did a curve and connected the 2 of them together. And then I explained and introduced the idea of expressions. These expressions are going to allow us to take something like this, where I'm working in feet, and put a slider that reads as inches, so 0 to 6 inches, and then add an expression right here. X divided by 12 will convert my 2 inches to a foot factor, essentially. So it comes out to be a 0.16667 for 2 inches in feet. Okay, so so that's just a quick recap of what I did. I'm heading a different direction than the subdivide surface, and I'm going to pause for a moment again real fast while I... What was I going to do for you again? You had a question, right? Somebody... Oh, you guys just wanted to catch up or something, right? Okay, yeah. So I'll give you guys a chance to catch up, and then I'll move into cleaning up this file because it's getting quite messy. And I think it's time to start incorporating some real management.